Today we're going to talk about graphing inequalities. So you already know how to solve inequalities, but today we're going to talk about how to graph them. And what I mean by that is how to graph your solution set on a number line to show all possible solutions for an inequality. So in this example, x minus 4 is less than 5. If we were to solve that, we would add 4 to both sides and get x has to be less than 9 to make this inequality true. And so when I say graph an inequality, you want to graph on a number line to show your solution set. So on my number line, I want to show that x can be all numbers less than 9. And I've done that here. And you may notice that I have an open circle on 9, and then I have an arrow going in the negative direction towards all the numbers that are less than 9. And I continue the arrow here over the end of the number line because it can go on forever in this direction. So just to show that it continues on in that direction, we just go over the end of the number line to show that it's a line that continues on forever. So since I want to include all the numbers less than 9, it does not include 9 itself because it has to be less than 9. So to show that it does not include 9, I put an open circle on top of the 9. But you may be thinking, why not just start at 8? If it doesn't include 9, why can't I just start here at 8 and draw my line down? And the reason for that is because you'll see here in between 8 and 9 there are a lot of numbers. There's decimals, and according to our solution set, x can be any number that is less than 9. So although it can't be 9, it can be 8.99999, which would be right before the actual 9. So if I started at 8, I would be missing all of these numbers in here, and that wouldn't be accurate. So to show the number closest to 9 that x could be without including 9, we have to put an open circle on 9. So that tells us the solution set does not include 9, but it includes everything touching up to touching that line and going this way. So this is how our final graph should look for the solution set. X is less than 9. I have an open circle on 9 and an arrow going towards the negatives that are less than 9, and it goes on forever. Okay, for this example, we have y plus 3 is greater than or equal to 7. When we solve that, we'll subtract 3 from both sides and get y is greater than or equal to 4. Now for this problem or inequality, we want to include 4 because it has the greater than or equal to. So y could be 4. So to show that it can be the number we're including it, we use a closed circle. So a closed circle means it includes that number that the circle is on. So 4 could be a solution for this inequality. Now y is greater than or equal to 4. So we're going to put our arrow towards the positive numbers in this direction to show that it's greater than 4. So y can be 4 or any of these numbers in between, and goes on forever in this direction. So let's just review. An open circle does not include the number, and you'll use an open circle when you have greater than or the less than sign. A closed circle includes the number, so you'll have a closed circle when you have greater than or equal to and less than or equal to. So looking at these examples, you can tell right away if you're going to use an open or closed circle. Since this is the greater than sign, you are just going to use an open circle. This is less than or equal to, so we use a closed circle for that one. And here are some on your own problems. I would like to see you solve each one, so get the variable alone, and then graph your solution set.